Hi, my name is Gardner. I'm a neuroscience student, and first of all I would just like to thank the Otago Medical Research Foundation and C&E Matheson for sponsoring my project. So we can think of the brain as working on electrical impulses, and for example, if we turn on one switch, the amount of light that we get is the amount of learning that occurs. So we can get really strong learning. But if prior to this, in a complete separate region of the brain, we also turn on the light, we also activate the brain, the amount of learning that we can get in a separate area is going to be less, so the light is dimmer. So we think that this naturally occurs as a way of conserving important memories or neural activation patterns. But in mouse models of Alzheimer's disease, this actually occurs. It's aberrantly engaged when it's not meant to be happening, and we think that this may contribute to cognitive decline that's seen in this kind of disorder. So my research has been investigating how this is occurring using techniques like electrophysiology and using drugs to activate certain receptors to try and figure out how it's occurring and maybe open up potential therapeutic targets for very untreatable diseases like Alzheimer's.